Hello everyone, and welcome to the second part in our intermediate webinar series, Making Figures with ggplot2, More Geoms and Different Types of Graphs. In this section, we're going to go over more geoms, and we're going to continue learning how to plot different types of graphs using ggplot2. For our example data, we're going to be using the same Assembly QC table from the previous section, and this is a table from the Assembly QC program Quest. We're going to read it in using the read.delim function into a variable called df. Now, the first type of figure we're going to go over are histograms, and to plot a histogram, we are going to use the geom histogram function. We'll start by plotting a histogram of N50. We need to load in ggplot2 using the library function. And the first thing you might notice here is, unlike the scatter plot and line plot from our previous section, we don't need to specify a y variable here. We just need to give the x variable we want plotted in our histogram. And ggplot will actually calculate the counts that will be on the y-axis for us. And then we just add the geom histogram function. Now, as you can see, R actually printed out a line of dialogue here that says statbin, which is a function, using bins equal to 30. Pick a better value with bin width. And what this is telling us is that by default, geom histogram sets the bins parameter equal to 30 by default, meaning that the data is binned into 30 separate bins. Based on our data, we might want to pick a better default for us. And when I look at this histogram, I see that it's widely dispersed across the data, so I want to go ahead and condense that histogram. And we're going to do that by changing the bins parameter. So within the geom histogram function, we set bins equal to 10 instead of the default of 30. And let's go ahead and run that. And here we have a much more condensed histogram than we did in the previous figure. So we can change the color of our histogram using what we learned about the AES function in the previous section, where if we want to make a uniform change to our histogram, within geom histogram we set bins equal to 10, as we did, color equal to black, which will give us a black outline, and fill equal to light green. And now I have a light green histogram with a black outline, so I can very easily see the differentiation between bars. If I wanted this to be blue instead, I absolutely could do that. And this gives us a dark blue histogram with a black outline. I believe you can actually specify dark blue as well. Yep, that is a recognized word. And that will give us an even darker histogram if we wanted it. So we can color our histogram by a specific variable using the AES function as well, and color or fill. Because oftentimes when we have a histogram, we're comparing histograms of multiple variables across a data set. And we can do this by setting fill equal to species within the AES function. So when we do that for species, we see that our Acinetobacter baumannii samples are colored in coral, and our Klebsiella pneumoniae samples are colored in blue. And personally, I've always found stacked histograms a little bit difficult to interpret unless the legend is very clear, or rather the description of the figure is very clear. So I'm going to go ahead and set the position parameter to something different. And the options for that include identity, stack, and dodge. In this case, I'm going to set it equal to dodge. And when I do that, I now have the Acinetobacter baumannii as separate bars and the Klebsiella pneumoniae samples as separate bars, but they're still colored by sample. ggplot has the ability to add a line at the mean or median of our histogram using the function geom_vline, and we add this to the geom histogram and ggplot functions that we've already defined. We need to set an x-intercept parameter, and we are going to go with median. I find that's generally more representative of data and less misleading than mean. We're going to set our line type equal to dashed and our size equal to 1. And we set these parameters within the AES function of our geom function. And we do that within the geom_line function because it is separate from our histogram plot. And now we have a dashed vertical line at the median of our data within our histogram plot. Now moving on to bar plots. To plot a bar plot, we use the geom bar. We're going to start by plotting the counts for each species in the data set. Now, to do that, we need to do the stat parameter set equal to count within geombar. And as a reminder, we can go in and take a look at the different parameters and their usage for geombar using the help documentation in the help tab or using the question mark. So let's go ahead and run that. And when we do that, we see that there are 9 Acinetobacter baumannii samples and 7 Klebsiella pneumoniae samples in our data set. And by default, our bars are plotted vertically instead of horizontally, but if we wanted to change that, we could use the chord flip function. So when we run that, we see that our samples are now horizontally plotted instead of vertically plotted. Color, fill, and AES can be used to color and fill the bars, just as it has been in all of our previous samples. If we wanted to color by species, we set color and fill equal to species, and all of our Acinetobacter baumannii samples are now colored in coral, and our Klebsiella pneumoniae samples are colored in teal. If we wanted to give a black outline to differentiate the bars rather than make the outline the same color as the bars, we would set fill equal to species within the AES function that's found within the ggplot function, and we would set color equal to black within the geombar function. And now our bar plot has black outlines and is colored within the bar by species. Multiple variables can be used in the bar plot. So if we wanted to plot the antimicrobial resistance counts and color the bar by species, we could do that. So let's go ahead and have our data be set to AMR. That's what we want to plot. We're going to put fill equal to species and color equal to species within the AES function found within the ggplot function. And we're going to set stat equal to count. And when we do that, we see that we now have 3 bars for our Acinetobacter baumannii samples because we have 3 separate antimicrobial resistance profiles for our Acinetobacter baumannii samples, and 1 bar for our Klebsiella pneumoniae samples because we only have 1 antimicrobial resistance profile for our Klebsiella pneumoniae samples. Now, the final plot type we're going to go over are box plots. To plot a box plot, we use the geom box plot. You may have noticed by now that these geoms have pretty intuitive names to them. We're going to plot a basic box plot of species versus total length. So x equal to species and y equal to total length within the AES function of the ggplot function. So here we have our Acinetobacter baumannii plot on the left and our Klebsiella pneumoniae plot on the right. And our data has some pretty stark outliers in it, where we have 1 really small Acinetobacter baumannii total length and 1 very large Klebsiella pneumoniae genome length. And those samples I would immediately flag as of poor quality, and I would want them removed from any downstream analyses. But for viewing the total lengths, the boxes of the box plots are actually quite thin, so we can remove those if we want by setting the outliers parameter equal to false within geom_box_plot. Now, this is a newer functionality in ggplot2, so make sure when you download ggplot2 that you have an up-to-date version, because in older versions, this will not work. So let's run that code, and now our outliers are gone. Now let's say we wanted to highlight our outliers again instead of remove them, because again, for QC purposes, I would want to look at samples that have these outlier lengths to them and flag them for removal in later data analysis steps. We can use the parameters outlier color, outlier shape, outlier size, etc. And if we wanted to take a look at these, let's go ahead and look at the geom_box_plot documentation. And we can see here that some of the parameters that are available are color, fill, shape, size, stroke, and alpha. We haven't discussed alpha, and I'm not going to go in depth to it in later examples, but alpha is very useful in that it allows us to set the opacity of our data. I'll show that in just a second. But let's go ahead and set our color equal to blue, our shape equal to 15, and our size equal to 3 for our outliers. And our outliers are now dark blue large squares on our data. Now, to demonstrate how alpha works to change the opacity, I am going to set alpha equal to 0.1, which is a very small alpha. Alpha ranges between 0 and 1. And now you can see that these squares are very light. To just show you an alternative situation, I will set alpha equal to 0.9, which is a higher value for alpha. And it's still pretty fairly opaque in this. To show you what 50% looks like, let's set it equal to 0.5. And now, as you can see, this is a mid-level opacity. And it's very useful when you have a very large data set with many overlapping points to change the alpha so that you can better see some data that might otherwise be obscured. Now, we can use chord flip to horizontally plot the boxes just as we did with our bar plots and histograms. And that will plot the box plots horizontally, as you can see in the plot tab here. And we can also use geom line or geom line to plot a horizontal line or a vertical line at some value on our graph. And for this, I'm going to go ahead and use geom line and a y-intercept at the mean of the total length. And I'm going to make that line type equal to dashed. And we do that within the AES layer of the geom line function. And now we have a dashed line here at the mean of our total length. And coloring our box plots by some variable, such as species in this case, is the same as previous examples where we change the fill within the AES function of our ggplot function. And we change the color equal to black, which will change the outline to black. And we do that within the geom_boxplot function. And now we have our boxes colored by their corresponding species with a black outline. Alternatively, we can set color equal to species within the AES function, which will give us the outline color corresponding to species. And we can leave geom_boxplot blank. And that will give us a white interior and an outline, the color corresponding to a particular species. So that's it for what we're going to go over for specific geoms for now. But in the next section, we're going to go over more ways to customize your figures. So thank you for listening, and I will see you in the next episode.